First, we discuss about capabilities of magnetic particle testing. Let's start the session. The first topic is purpose and capabilities. The main purpose of magnetic particle testing is to detect flaws in ferromagnetic materials, both during manufacturing and after they have been in service. That means the protection discontinuity and in-service damage. Think of it as an early warning system. We want to find defects before they cause a failure. That is the two main situations during manufacturing and during in service. First, during the protection, MPT is used to detect protection manufacturing that occur while making the part. Example, seams, laps, grinding cracks and quenching cracks. In seams, longitudinal surface defects formed during rolling and forging. Same time, the laps, folds or rolled over metal on the surface. Grinding cracks means small cracks caused by excessive grinding heat. Quenching cracks means thermal cracks from rapid cooling in heat treatment. These defects weaken the part's structural integrity from the very start. Then in-service damage during the service. MPT can also detect in-service damage also. Example, fatigue crack and overload crack. Fatigue crack is caused by repeated loading cycle and overload crack caused by a single excessive force. This allows maintenance team to repair or replace the part before catastrophic failure happens. Then MPT is not just about finding any defect. It has specific capabilities that make it powerful. First one is material restriction. It works only on ferromagnetic materials, metals that can be strongly magnetized. Common example is carbon steel, low alloy steel and nickel, cobalt. This is the common ferromagnetic material and not suitable for non-magnetic materials like glass, ceramics, plastics, aluminium, magnesium. These all not suitable for non-magnetic material. And the next point is MPT is excellent for surface defects like cracks, seams and laps. Can also detect slightly subsurface defects. Already we know that what are the surface and what are the subsurface. This is the surface and this 1.5 mm to 3 mm itself is the subsurface. It can also detect slightly subsurface defects depending on the depth, size and shape, type of magnetic field and field strength. First we look at depth. Shallow cracks are easier to detect and size and shape is sharp and narrow cracks cause stronger leakage fields. Then what are the type of magnetic fields we are using? AC, DC and half-wave DC. And the next is field strength. The stronger the magnetic field, the deeper it can penetrate into the material. If the field strength is weak, then the magnetization may not reach deep into the material, which means small or deeper cracks might be missed. And the current type already we know AC, DC and half-wave DC we are used. The next one is MPT can confirm that machining, grinding or heat treating has not introduced new defects. For example, after grinding a shaft, we can check that is no grinding cracks are present. Like example, we check heat treatment. Heat treatment involves heating and cooling the material to change its properties. If done incorrectly, it can cause quenching cracks or other thermal damage. After these operations, MPT can be applied as a quality check to ensure no new discontinuities have formed, helping maintain product integrity before the part moves to the next stage or it goes into the service. The next topic is the process overview. The first step is to induce a magnetic field inside the part. This can be done by three ways: direct magnetization and indirect magnetization, or using permanent magnets or electromagnetic yokes. The goal is to align the magnetic domains so that the path is fully magnetized. When the path is magnetized, any crack or discontinuity will cause magnetic flux leakage at the spot. That is the first step. The next one is magnetic particles are applied. The magnetic particles are applied to the surface. Either it can be dry or wet suspension in oil or water. In visible method, the particles are colored, that means black, red or yellow, to contrast with the surface. In fluorescent method, particles glow under UV light for better visibility. The particles are attracted to flux leakage areas, the point where the magnetic field escapes due to the flaw. That is the second point. Next is patterns formed or interpreted and compared to codes or standards for acceptance. When particles gather at a leakage field, they form a visible indication of the defect location, size and shape. The inspector examines these patterns and compares them to the acceptance criteria in relevant code and standard or customer specification. For example, ASME and ASTM and API standards. These are define the maximum allowable defect size depending on the part service. So next one is often requires two magnetization directions. Yes, the magnetic particle is directional. It detects defects best when they are roughly perpendicular to the magnetic field. If magnetic field flow is north to south, means our defect is perpendicular to east to west, perpendicular to the magnetic field in the direction of east to west. If the crack is parallel to the field, the flux leakage may be minimal or absent and the defect could be missed. That's why for full coverage, we usually apply magnetization in two directions. One parallel to the part's axis and one perpendicular to the part's axis. This ensures that defects in any orientation have a chance to be detected. And the next topic is advantages. First one is simple and cost effective. It's easy to perform and cheaper than most other NDT methods. Second, only to visual inspection. This is only allowed to the visual inspection. The next one is can detect flaws too small to be seen by the naked eye. It finds very small defects also. The next one is it can be used on finished parts only, like gears, shafts, as well as raw materials like billets, bars, castings and forgings. It's applicable to a wide range of ferromagnetic products. The next topic is limitations. MPT can only be used on ferromagnetic metals like carbon steel, nickel, cobalt and low alloy steel. It won't work on non-magnetic materials like aluminium and copper, stainless steels, these. This is the main limitation. It works on only ferromagnetic, that means magnetizable material. The next one is large cross sections path may require high current. Thick or large cross section parts may require very high electric current to magnetize properly. For example, a large steel shaft or thick walled pipe may require a very high electrical current to produce adequate magnetization. This can demand more powerful equipment and special handling to avoid overheating or damaging the part. The next one is the magnetic field is directional. MPT detects flaws best when they are oriented perpendicular to the magnetic field lines. This is flux field lines. This is crack or any defects. So magnetic field is in this direction and the defect is perpendicular to the magnetic field. Then defects that are parallel to the field may not produce enough flux leakage to be detected. To overcome this, multiple magnetization, that means different directions are often required, typically two right angles to ensure full coverage. The next topic is training objective. First point is the basic knowledge and the quality and entity personal, the basic understanding of how magnetic particle testing works and when to use it. This is provide a fundamental knowledge for quality assurance. The next one is enable proper technique selection, accurate interpretation and evaluation of result. In MPT, we are using different parts and defect types may require different magnetization methods. That means yoke, prod, coil and central conductor, and particle types are dry, wet and visible particles and fluorescent type. That all are different methods and different parts. So we can use proper technique selection and trained personnel can select the right technique for the job to maximize defect detection probability. They can also interpret particle patterns correctly, knowing the difference between a true defect indication and a non-relevant indication. Example, it caused by a geometry or surface condition. The next point is help identify ambiguous indication that may require retesting or expert review. Not every indication is straightforward. Some may be borderline or unclear due to low contrast or a weak leakage field or surface contamination. Only well-trained inspectors know when to clean and retest the area, change the magnetization direction or field strength. So the inspectors know when an indication is unclear so they can retest or ask an expert before deciding. These are the capabilities of magnetic particle testing. Thank you. I hope you all understanding this concept and let's see the next video. Thank you.